In this lecture, we will learn the main steps of an energy audit process. In particular, an energy audit can be defined as an inspection, survey, and analysis of energy flows for energy conservation in a building, process, or system. A formal examination process including the identification of each energy-consuming device in a building or facility, the determination of the number of operative hours, and the calculation of the rate of energy use. The final aim is to exactly quantify specific energy consumptions and reduce the amount of energy input into the system without negatively affecting the output. The main activities of an audit process can be identified as follows. The analysis of building energy utility data, including study of the installed equipment and analysis of energy bills. The site survey, including specific measurements if necessary. The assessment of the building behavior and of the interactions with the weather, occupancy, and operating schedules. The identification of customer concerns and needs. The selection of the evaluation of energy conservation measures. The estimation of energy and cost-saving potential. The verification of actual savings after energy retrofit by means of specific monitoring activity. Generally, 4 levels of analysis can be outlined. Level 0, benchmarking. It is based on the assessment of the historic utility bills and costs and on the comparison of the performances of the building to that of similar buildings. This benchmarking allows determining if additional analysis is required. Level 1, walkthrough audit. It is a preliminary analysis made to assess building energy efficiency to identify not only simple and low-cost improvements, but also a list of energy conservation measures to orient the future detailed audit. This inspection is based on visual verifications, on the list of installed equipment and operating data, and on the detailed analysis of recorded energy consumption collected during the benchmarking phase. Level 2, detailed energy audit. Based on the results of Level 1, this type of energy audit consists of the energy use survey in order to provide a comprehensive view of the building with a breakdown of the energy use and a first quantitative evaluation of the possible energy conservation measures. This level of analysis can involve advanced on-site measurements and computer-based simulations to exactly evaluate the selected energy retrofits. Level 3, investment-grade audit. It is a comprehensive analysis of capital-intensive modifications, focusing on deep energy conservation measures, requiring rigorous engineering study and the detailed design of retrofit interventions. Now, let's explore the main information to be collected during an energy audit process. 1. General characteristics of the building, such as floor area, net volume, glazed surface, opaque surface, etc. 2. Monthly energy bills of electricity, natural gas, and other energy vectors. 3. Occupancy profiles and users' needs and concerns. 4. Type and main feature of HVAC equipment, such as chiller, air handling units, etc. Artificial lights and other equipment, such as personal computers, lifts, etc. 5. Usage profile of main systems and equipment. 6. Control strategy of various systems, such as sensor, control logic, etc. Although much data and features about systems can be obtained from design schemes or interviews to O&M personnel, the information may not be adequate to provide a full picture of their operation. For instance, if just aggregated electricity consumptions are available and no information of the share among the specific functions, such as air conditioning and lighting, is existing. To obtain accurate operating conditions and performances of systems, the auditor should have appropriate measuring instruments, such as portable sensor for spot measurements, such as infrared camera or current clamp, standalone sensor with data logger for short-term measurement, full monitoring system for long-term measurements. During the measurement, the sensor should be located at points that can best reflect the need or function of the control parameters. For example, for the office environment, a lux meter should be placed at about 80 centimeters above floor level or at the level of the working plane, and a thermometer at about 1.1 meters above floor level to measure the seating thermal comfort. The collected data on energy consumption and the measurements are typically non-referred to the same period or the same boundary conditions, for example, different occupancy rates or climatic conditions. For more accurate comparison, this data should be normalized on specific indicators, for example, kilowatt-hour for heating degree days or kilowatt-hour for employee. Measured or collected data must be analyzed to obtain a detailed overview of the energy behavior of the building and of the contribution of the different functions. Specific data processing techniques can be adopted, such as the energy signature. In detail, plotting for several time periods the average heating or cooling power versus average external temperature allows a fast detection of malfunctions and provide a useful information on the building's energy performance. This method assumes constant internal temperature, and thus external temperature is the most influential parameter. It is useful in buildings with stable internal gains and relatively low passive solar gains. In conclusion, the audit process involves both on-field and data processing activities, goes through the assessment of user behaviors and needs, the selection of energy conservation measures, the estimation of energy and cost-saving potential, and the verification of actual savings.